Okay, we're going to continue this example, our first part of our video cut out. So we need to factor everything. The numerator is fine the way it is. Denominator would factor into x minus 5 and x minus 1. And here's another example of where neither of those denominators is going to cancel out. So we're looking at ones where they don't cancel. Our points of discontinuity, the things that make our denominator 0, is when x is 5 and when x is 1. Okay? And since neither one of those can be canceled out, we have vertical asymptotes at both of those. So let's draw those in. We have a vertical asymptote at x equals 1 and another one at 5. Okay? And we have no holes again because we had no points of discontinuity that could be canceled out. Looking for our horizontal asymptote, we have our first top degree is 1 and our bottom degree is 2. So we have a situation where less over more. Smaller degree on top means we have a horizontal asymptote at y equals 0. Again, you can abbreviate that HA. So y equals 0 would be right here. Then we need to find our other points. And we said finding those intercepts was required before we go to our calculator. So let's start with finding our Y-intercept. That is the value for y when x is 0. And we can plug that 0 into either the factored version or the unfactored version. Since we used the factored version on the first time, in the previous example, I'm going to go ahead and use the unfactored version right now. So we have x plus 3 over x squared minus 6x plus 5. If we plug zeros in for all of our x's, we have 0 plus 3, which is 3. Denominator 0 squared minus 6 times 0, that all drops out, and we just have a 5. So our X-intercept is going to be at 3/5. Sorry, our Y-intercept at 3/5. Okay, so we can plot that 0, 3/5. Okay, to find our X-intercept, we need to plug a 0 in for y. And we said that when we put a 0 in for y, putting a 0 here, really when we cross multiply, it cancels out that denominator. And so we're really just looking at what makes the numerator equal to 0. And since our numerator is x plus 3, it equals 0 when x is negative 3. All right, so let's go ahead and plot that. All right, so we have an X-intercept that's actually on a horizontal asymptote. And that's okay. We can never touch vertical asymptotes, but we can cross a horizontal asymptote because the horizontal asymptote is really there to show us what our graph is doing on the far sides, the far left and the far right of our graph, not what's happening close to the origin. All right, so let's go to our calculator and see what else we can find out. All right, we'll clear out our old equation. And we're going to type in our new one. So y equals parentheses x plus 3 divided by parentheses x squared minus 6x plus 5. All right, and we're going to graph it. Now, I am going to change the window a little bit so we can see what's happening where we were crossing the horizontal asymptote. Because remember, we had vertical asymptotes at 1 and at 5. So this part of our graph is making sense. We have an upside down, almost a parabola shape, not quite, in between our asymptotes, and then we have a branch on the right side of our vertical asymptote. And again, we can go to our table of values and find some points to plot. So let's say we are looking at maybe an x value of 2 and 4. We could look those up. And then also we could try something at, say, 6 and 7 at some of those points. Okay, so let's go to our table. All right, so when x is 2, we were at about negative 1.6. And at x being 4, we were at negative 2.3. So negative 1.7, we'll say, and negative 2.3. All right, so when x was 2, we were at negative 1.7. When x was 4, we were at negative 2.3. Let's go ahead and plot those just so we have a couple points in here to aim at. And then at 4, we were at negative 2.3. So we had kind of this upside down kind of U-shaped graph. Try to actually hit your points. Okay? All right. Let's go back to our calculator. And if we know we have a vertical asymptote at 5, so let's look at a couple, again, vertical asymptotes where we had those errors for y. Let's look at a couple more points, like these. At 6, we're at 1.8, and at 7, we're at 0.8. Okay, so at 6, we were at 1.8, and at 7, we were at 0.8. So we have another branch that's coming down here and leveling off just above the x-axis. So what I really want to focus on now is what's happening on the far left. So let's go ahead and we're going to change our window a little bit, because when we just graph from negative 10 to 10, it's a little hard to see what's happening in here. But if we zoom in and just look at this part of our graph, right in here, then we can see that we're actually dipping below the x-axis there. All right, so let's zoom in, and let's say we only go from negative 2 to 2 for y, and we just look to the left of, say, our vertical asymptote at 1. All right, so for our window, let's say our x's are going from negative 10 to 1, where that vertical asymptote was, and our y's, we're only going to go from negative 2 to 2. See what happens there. All right, so you can kind of see our blue graph here is just underneath the x-axis, and then it crosses here at negative 3, which we knew was our X-intercept. Okay, so our graph should be coming down here, going through our Y-intercept here, going through our X-intercept, and then leveling off just underneath that horizontal asymptote. All right, let's look at one more example, and we are going to change it. I'd like you to change this top equation to be, get another room, more room here, 2x squared minus 2x minus 4. Okay, 2x squared minus 2x minus 4. So when we factor, we can take a 2 out of that. It leaves me x squared minus x minus 2, which was my original problem, over x squared minus plus 3x minus 10. That will factor into x and x, multiplying to be negative 10 and adding up to 3 would be positive 5 and negative 2. And let's factor that numerator a little bit further. We can take that x squared minus x minus 2 and factor it into x minus 2 and x plus 1. All right, so our factored version, I'll put it over here. We have 2 times x minus 2 and x plus 1 over x plus 5 and x minus 2. So we have 2 points of discontinuity again. One when x equals -5 and one when x equals 2. Those are the 2 places that make the denominator 0. They would be domain restrictions. Because I can cancel out the x minus 2, this is a case where it does cancel. That means we have a hole at x being 2. So we're going to actually have to find our y-coordinate for that hole. We'll come back to that. The other point of discontinuity was this -5, and since we can't reduce this piece out, that is a vertical asymptote. All right. Looking at our simplified version, if we take out the x minus 2's, we have 2 times x plus 1 divided by x minus 5. And if we plug a 2 in for our x, the top becomes 2 times 2 plus 1, 2 times 3 would be 6 for the numerator. Denominator, putting a 2 in there gets us 2 minus 5, which is -3. And we end up with -2 for our whole. Sorry, this is supposed to be a plus 5 here, x plus 5, so we end up with 6/7 for our whole. Okay, so let's plot what we know so far. We have a vertical asymptote at -5. And we have a hole at the point 2 6/7. So 2 and almost up to 1. So there's a hole right down there. All right, looking at horizontal asymptote. Going to our original problem, we had a leading coefficient, we had a degree here of 2 on top and on the bottom. So this is a same equals same. So do you remember the rules? If we had the same degree on top that we have on the bottom, we ended up having to look at the leading coefficients. And our leading coefficients here would be a 2 on top and a 1 on the bottom. So we have the equation y equals 2 divided by 1, or just y equals 2. So let's go ahead and draw that in. Horizontal asymptote at y equals 2. Okay, finding our intercepts. Again, we are going to use our simplified version. So we have y equals 2 times x plus 1 divided by x plus 5. That's my simplified version. And if I put a 0 in for x, I end up with 2 times 1 for the numerator, which is 2, and 0 plus 5 is 5. So 2/5 would be my y-intercept. So 0 2/5. We have point, let's make that a little bit lower. 0 2/5. Okay, and then if we plug a 0 in for y, we're really just looking at the numerator. What makes the numerator equal to 0? And the only thing that makes a 0 here would be a -1. All right, let's plot that point, -1, 0. All right, so if I had to make a guess, I'm expecting there to be some kind of branch down here that's going to come up, go through those 2 points, and skip over my hole and curve that way. Now, I do know that there has to be more on the left of my vertical asymptote. Those vertical asymptotes are in there to break our graph up. So there's got to be another branch over there somewhere. But we don't really have any points plotted. So let's go to our calculator. We'll clear that out again. This time we're going to plug in parentheses 2x squared minus 2x minus 4 divided by parentheses x squared plus 3x minus 10.